In this session, we'll discuss references. So as you have seen, variables are used to store strings or integer values or list. However, this is a very simplified way of saying, but technically speaking, variables are actually storing the references to the computer memory locations where the values are stored. So suppose, let's say I write a statement spam is equal to 42. I have been always saying that 42 is stored in the variable spam. But technically speaking, spam will actually contain the reference to this number 42. See this diagram. 42 is the value. Okay, now that will be stored somewhere in a memory location. Let's assume that this blue box is actually the memory, right? So in a so the computer actually searches for a free memory, and suppose this is the area which is assigned and 42 is stored here. The variable spam actually stores the reference to this. Spam variable does not contain the value 42, but it contains the reference to this. In the sense, it contains the address of that memory location where the value 42 is stored. So when I say reference, it means the address of that memory location where the value 42 is stored. So spam is storing the reference to this computer memory location. Okay, so let's try this on the IDLE's screen to get a better idea of what is this. Let's take an example and say that spam is equal to 42. Now what does spam contain? Spam actually contains the reference to this value 42, but here it will show the value which is stored at that address. So the next line, let's say I will change the value of, let's say I will equate cheese to spam. So that means I'm assigning spam to cheese. And now let's say I'm changing the value of spam, which was earlier 42. Now I'm going to change it to 100. Now let's try to see what is there in spam now and what is there in cheese. So if you print spam, you see that spam is containing the value of 100 because just now I have changed the value of this spam to 100. And if you display cheese, you see that the value is 42. Now why does this happen? If you actually see the reference, if you actually want to see in which memory location the value 42 is stored, or in which memory location this cheese is referencing to, we can just do it by using the keyword ID and then type spam. So what does ID do? It returns the identity of the object or the address or the reference. So as I already told you, spam contains the reference to the number 42. So what is the reference? It is the address of the memory location. So you can actually see that address. So address you can see by typing ID. So ID of spam. So this is a memory location address at which the value of 42 or 100 now is stored. So if I see the ID of cheese, so this is a memory location's address where this cheese variable is pointing to. So as you can see that both of them are having different IDs, right? So spam is pointing to a different memory location and cheese is pointing to a different memory location. So what does that mean? So when I assigned in the first line, when I assigned 42 to the spam, you're actually creating 42 in the memory and storing a reference to it in the spam. And in the second line, when I assigned spam to cheese, what happened there? You copied the value in spam and assigned it to the variable cheese. So we just copied the value. So you're actually copying the reference. Okay. In the first case, spam and cheese therefore are referring to the 42 value in the computer's memory address. And if you want to access the memory address, you just have to use the ID function. Later in the third line, what we did is we created a 100. We changed the value of spam to 100. And here is the difference. What happened when I changed the value of spam to 100? You created a new 100 value in the memory location, and that reference is now stored in spam. So now spam is going to have a different ID. Okay. So let's just revise again. When I first said spam is equal to 42, a value 42 was assigned in a memory location and the reference to it or the address to it was stored in the variable spam. In the second line, when I said cheese is equal to spam, a copy of this value is is created and it is assigned to the variable cheese. Now both spam and cheese are pointing it to the same location. They're pointing it to the same reference. Okay. So in the next line, third line, when I said spam is equal to 100, one more memory location, in another memory location the value 100 gets stored and spam is now referencing to this. So at this point of time only cheese is pointing to the value 42 and spam is pointing to 100. So that is the reason why the IDs of spam and ID of cheese was different. When we saw that in the IDLE screen, the address was different. So that is why this. Now why does this happen is because we are now talking about 42, which is an integer. An integer is an immutable value. That means it doesn't change. Changing the spam variable is actually making it to refer it to a completely different value in memory. So when I changed spam value, we actually made it point to a different memory location. Okay, now let's try to see, we will try to do the same program, but instead of that we are now going to use list. Instead of storing integer 42 in spam, let's store a list in spam. Okay, and as I've already discussed, lists are mutable. That means they can be modified, they can be changed. So we are doing the same thing here again. Initially there we had spam is equal to 42. Now I'm going to assign a list to spam. And in the second line I'm going to do the same thing. I'm going to write cheese is equal to spam. So what happens here? First, when in the first line in the memory location the list value is stored and spam is pointing to it. After the second line is executed, cheese is equal to spam, cheese is also pointing to this same memory location. Now let's say I change the value of one of the items in list of cheese. So I say cheese of 1 is equal to hello. So then what happens? This changes the list value. We are changing the list value and therefore this is the new list value. Actually what is happening is the same list value is getting updated. It is the same thing. We are not having a new memory location. New memory location is not created. It is the same thing is updated. This is updation. Now this is not a different memory location, it is the updation. The old memory list is now updated to a new memory list at the same location itself. So that is why you can see that cheese and spam will still point to the same thing, and therefore when you display spam and cheese, you should now get the new value of the list. Now let's try this on the IDLE screen. We will do something similar to the above lines, except that now I'll be using a list. Okay, spam is equal to a list now, and now I will say cheese is equal to spam. Now I'm going to modify the value of cheese. You can modify spam or you can modify cheese. It's the same thing. So let's say I change this to, let me put a number itself. So now let's see what is the value of cheese. See, the first index, the item at the first index is updated. Let's see the value of spam. See, even spam has got updated and it is the same thing. See the difference between the previous program here and this program here. In the previous program, I have done the same steps. Only difference is instead of using integer, I am using a list. The integer is immutable, list is mutable. Otherwise, all the steps are same. But in the previous program, what happened? Spam value was only updated, cheese was not updated. But here you can see both cheese and spam is updated. Now why this has happened is it is remaining at the same, you are updating the list at the same place. You are not changing it. A new memory location is not created. Okay, so if I see the ID of cheese and ID of spam, see, both of them are showing the same memory. That means what? Both of them are pointing to the same memory reference. A new memory location is not created. That's the difference. Okay, and why does this happen is because lists are mutable. You can change the value within the list, and that's the reason. So list itself was never actually copied. It was just modified. Okay, so let's illustrate the same thing in the form of a diagram. This is a case 1, right? Initially I had spam is equal to, I created a list and assigned it to spam. So what is this? This is actually the memory location. Okay, in the memory location we are storing this list, and what is this? ID. That means the address of this memory location. And what is this? Spam. So spam is actually pointing to this memory location. That means spam is containing this ID. Spam is containing the ID. So it's like a container. Okay. So spam is containing the ID. The same thing. 572074444. In the next step, what did we do? We wrote cheese is equal to spam. So what happened? We created one more variable called as cheese, which is again pointing to the same memory location. So if you see, both spam and cheese are having the same memory address. Okay. Now in the third step we made modification, right? We modified one of the value of cheese. So I said cheese of 1 is hello. So when I did that, that list itself is modified. A new memory location is not created, unlike in an integer. So you can see that both are still pointing to the same memory location, and the value within this list is modified. Okay, so the reason why this happened is because lists are mutable, they are modifiable, whereas integers are immutable, you cannot modify. Okay, and always remember that technically variables will contain reference to the values. Right? Variables in the sense, spam, when I said spam is equal to this 0, 1, 2, 3, 4, 5, spam actually contains a reference to it. It does not actually contain 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5 will be existing somewhere in a memory location, and spam will contain the address of that memory location or the reference to that memory location. But people often casually say that variables contain the value. That's just a casual way of saying, but technically the variables will contain a reference to the values. Please remember this. Okay, so try both these programs. Only when you see the programs you can actually observe. You observe the memory address where they are stored by just typing the ID. So then you can get an idea of how the variables are storing the address and what's the difference between how lists works and how integers are working. Okay, thank you.